that I was almost forgetting. Okay, so we will use this example of defective items. Okay, and you can see the probability of finding the number of defective items. That is, it's either no, that is 0 meaning no defective, that is item, up to 30 meaning we might have one defective item, we might have two defective items, we might have three defective items, and we can also have all our items defective. Okay, so in this case we are trying to that is to do what, to do that is the count of maybe defective items. Okay, so I will go up to 30. So that is we have 0 up to 30. It might be maybe 0 defective item, all that up to 30. Okay, all right, now let's come to that is just a minute. Okay, so in this case let me just expand. So guys, just to make sure we are together, so we have x in that is our x. What was our x? It was number of successful trials. Okay, number of successful trials. So maybe in this case we might have 0 successful trial, we might have 1 successful trial, we might have 2 successful trials, up to 30 successful trials. Okay, so 30 is the total number of trials, and remember that we don't know, that is the probability of having all those that is trials being what, being successful. Okay, so in this case our x marks the successful trials, n is the what, is the total number of trials, total number of trials. Okay, then we have p. Of course here we have two chances. Okay, the probability, it is will be the same. That is the probability of having a defective that is item, and probability of not having defective item, okay, will be the same. And in this case we are going to use 50%, which is 0.5. Okay, also we have what, of course these are the most important that is things we need to perform what, we need to perform binomial distribution. Okay, so remember the formula of binomial distribution. We say that it is let me just instead of opening another file to illustrate, let me just take that is formula for binomial, formula for binomial distribution. Okay, so it's this one, it's the same as whichever, or that is the one we used. N, that is nx here, basically means n combine x. So in fact I can just take this part, okay, can just take this part, and this is what, this is our formula. Okay, so in this case we will need what, we'll need n that is n combine what, n combine x, n combine x, sorry, n combine x. So for this we are going to use an inbuilt excel. We'll also need what, p raised to what, p raised to x, that is the probability of success. Okay, the probability of success raised to what, raised to x. We also need that is probability of not success raised to what? To n minus what? To n minus x. If you can remember, this is the formula which we had illustrated when we were that is dealing with what? With binomial distribution. Okay, so in this case, let's say we have, that is our p. Okay, we have p, whereby our p is 0. What? It's 0.5, because it is a probability of success, meaning 1 minus p will be also 0.0.5. Correct. This is probability of not success. This is probability of success. Okay, we have our n, which is what? Our n, it is 30. Okay, because we are having 30 trials. Okay, so we have n, we have that is 1 minus p, and we have the value of p. Okay, and then we also have n minus what? N minus x. Okay, so for n minus x, it will be now equal to, of course, this will have to calculate as what? As a column here. We'll have to calculate this as a column, because x is varying. Okay, because x is varying. So this is the mathematical. Okay, this is the mathematical way of calculating binomial distribution or binomial probabilities. Okay, so remember our answer here. Okay, or our question is to find the probability that all the 30 trials will be what? Will be successful, given a probability of what? Given a probability of p. Okay, so that's what we are trying to check. Okay, all right, so in this case, I hope we are together up to that point, guys, so that I may not be rushing. Are we together? Maybe by show of thumbs up if we are together up to that point. Okay, thank you. All right, good. So now we want to that is to calculate n combine x. Remember, I showed you how we can express n combine x using factorial. That was more of that is expression, like we did it using a formula, and also tried to do an example. Okay, but now in Excel, we will have to use now combination formula. Okay, so we have a combine function. Okay, so what is our x? We know n, it's 30, and these are our what? They are our x values, or the number of successful trials. Okay, we might have a 0 successful trials, meaning we won't have any successful trial. We might have 1 successful trial, meaning maybe in this case, for our bulb, maybe we have 1 bulb out of 30. Okay, lighting, 2 out of 30 bulbs lighting, 3 out of 30 bulbs lighting. Okay, these are the successful what? Trials. Okay, so in this case, we are going to say it is equal to combine. We are just going to use combine. We have comp in. Okay, comp in, and you can see it will return, or it returns the number of combinations for what? For a given number of items. Okay, so in this case, we are going to say combine, that is a number. Of course, we need the number of combinations, which is now the number, and our number is what? Is 30. Okay, then comma the chosen number. So we want to combine n x times, so we are going to choose x. Okay, remember, we are going to reference n. Okay, we are going to reference n, but x is changing. Okay, but x is changing, so we have to do what? We have to, that is as well, um, and not lock it. Okay, so you can see this will be the outcome. And if you observe, okay, if you observe, that is the trend here, we will have like a maximum value. You can see this is the maximum value, but now, as maybe the number of trials are reducing and also the number of trials are increasing from the middle value, okay, you can see it is assuming the same value. You can see it is assuming the same values. That is, the values which are here are the values which are what? Are on this side. Okay. And if you want, you can try using now the broken down formula for combination. That is now using the factorials. Okay. Of course, now we have our probability. We had assumed that our probability is 0 point what? 0.5. That is, it is a 50-50 chance. Okay. Maybe the bulb will light or will not light. Okay. So that is a 50-50% chances. Okay. Even though at some point you might be given, that is a special condition, that is the probability of success, it is what? It is 80%, meaning it will be 0.8. Okay, and then probability of not success will be 0.2. At some point, depending with maybe the efficiency, we are assuming this is like a new company, okay, and they are trying out their production process to see if it is efficient and also accurate. Okay, but of course, if we have, that is a company which has already been in operation, doing the same, that is work, it must have, that is some efficiency when it comes to production. So in this case, the probability of having that is of a successful non-defective item will be what? Will be high. Okay, but here we are going to choose the chance of 50-50. But at some cases, you might be what? You might be guided to use maybe a certain set probability. Okay, so in this case, we are going to say 0.5%, that is 0.5, which is our 50% probability, raised to what? The number of successful outcomes. So we are going to raise that, and then we are going to drag it down. Okay, yes, up to that point. So this is our probability, that is our probability of success raised to the number of what? To the number of success. So in this case, we now have n minus what? Minus x. So we know our n is 30, and we need to minus the number of what? Successful, that is trials. So in this case, we are going to calculate n minus what? N minus x. Then after that, now we need the probability of what? The probability of that is of having a defect, or the probability of that is of course, yes, of having a defect, because our probability p, it's the probability of having a success, then this is the probability of failure. So in this case, we are going to say it is 1 equal to, okay, it will be equal to into 1 minus the probability of success, which is 0.5, okay, then raised to the what? To the to n minus x, and we already have n minus x here. So in this case, we are going now to calculate what? We are going now to calculate all this. Okay, yes, and this will be our outcome. Okay, now we need the probabilities, or we need, that is the probability of what? Of x. Okay, so it will be probability that will have 0 successful outcomes, or one that is will have 0, like we won't have any bulb which is lighting, probability of having one bulb lighting, probability of having two bulbs lighting, probability of having three bulbs lighting, up to probability of having all those 30 bulbs lighting. Okay, so in this case we are going to say it is now equal to that is n combined x, which is this one, multiplied by probability of p, that is a probability of success raised to the to x, which will be this, multiply by the probability of not success raised to the number of non-success trials. So we are going to combine with this. Okay, and then after this, now we can now drag it down. Okay, we can now drag it down and see that is how our probabilities will look like. Okay, yes, so in this case, I can also do some conditional formatting so that I might have maybe the probabilities well visualized. So in this case, since we assumed that is the probability of 30, 30, okay, of 30, that is, sorry, of 50, 50, then you will find that the what? You will find that you'll find that the probability will be highest at the what? At the middle of what? Or at the, let's say, the half, like you'll find that where we have the center, or where we have the mean of the what? The mean of all these bulbs, okay? You'll find that the probability of maybe having 15 bulbs lighting, okay, will be higher, okay, compared to the probability of having 27, okay, or 28 bulbs lighting, okay. And also you will find that with the probability of having 3 bulbs lighting is less compared to that of having 15 bulbs lighting, okay. So in case maybe we increase the probability of success, then you will see now that is, you'll see this changing. Okay, maybe let's try that first of all. Let's first of all try to present this in a graphical what? In a graphical representation. Okay, but before doing that, we want to see if we use the inbuilt function, okay, if we use the inbuilt Excel function, we are going to get what? We are going to get the same values. Okay, so in this case, I'm going to use binomial distribution. We have binom, okay, binom dist, okay. So binomial distribution, it returns the individual term binomial distribution probabilities, okay. So we are going to use binomial distribution, and in this case we'll need that is the number of success, okay, that is number of s. So this is number of successful trials, okay. So in this we are going to select x. Then we need the probability of what? Success. We also need now the probability of success, which is 0. What? Which is 0.5. Okay, then, sorry, before that, we have, I didn't see this, we have a number of successful trials divided by, that is comma, then the total number of trials. So here is the total number of trials. Then we need the probability of successful trials, which is this one. Okay, then we need the probability mass function. Okay, the formula itself will guide you. All right, and then since we are referencing these two cells, we'll have to log what? We'll have to log our, that is probability of success and the number of successful outcomes. And then once you drag, okay, once you drag it down, you can see we are getting the same values. Okay, we are getting the same values, meaning that is our probability is what? That is our calculation. We are correct. So you can see we are getting the same outcome. Okay, All right, good. What if maybe now we change what? We change, let's just try to visualize this. Let's try to visualize this. So we want that, and I will use this one. It's all the same because I want to change maybe the probabilities. Okay, and see what effect we will have. So in this case, I'm going to, yeah, that is to insert, and since this is that is a discrete distribution, I'm going to use what? I'm going to use that is a bar chart. Okay, I'm going to use a bar chart. So you can see in this case, if that is our probabilities are 50-50, then you can see that is average of our the probability of having that is average of the total bulbs tested. Okay, all the total number of trials tested will what? Will be having the highest probability. Okay, what if maybe we change the probability? Let's assume now the probability of success on our side, it is 80%. That is 0.8, meaning we'll have more bulbs, okay, that is more trials being successful, and that's why you can see the probability has shifted to what? To more, that is more values, and you can see it is high, like meaning at this point the probability of having 24 that is 24 um, um, bulbs that is being successful, it will be what? It will be, it will that is the probability, it will be high at this that is at this point. Okay, the probability of having that is 24 and if maybe if we want to do what? We want to confirm that, we'll say maybe um, equal to, maybe let's say 30 multiplied by 80%, meaning 80% of the bulbs will be what? Will be 80% of the bulbs will be okay. So in that case, you can see we are even getting what? 24%. That is 24 bulbs. That's why you can see the probability is high where we have 24 what? 24 number of that is 24 successful trials. Okay. All right. If maybe you change this to 90, 0.9, of course it will shift towards what? Towards 30. And you can see the probability is high at what? At that is 20, at 27. Okay. Meaning it will be 90% of the what? Of our that is successful trials. Okay, meaning we'll have 27, around 27 bulbs will light. Okay, will light successfully. So you can see that is how the binomial distribution is majorly that is used. Okay, these are the areas maybe where we can apply what? Binomial distribution. Maybe you can go and do another example. Okay, on your own. You can see in this case, we are given the probability, like we are saying, let's say the probability of drivers who do not possess a car insurance, it's what? 0.2 or 20%. So of course here you are going to use probability of 20%, as well as here probability of 20%. Here you are going to use probability of what? 45% or 0.45. So it all depends. Okay, you can be given that is probability values. Okay, yes, and this is how that is the probability affects, let's say, the probability of success affects the what? Affects the norm, that is the binomial distribution. Are we together maybe up to that point? If we are together up to that point, maybe by show of thumbs up, or if you have questions. Okay, I can really see only few people are reacting. Janvia, are we okay? I didn't see your reaction. Uh, uh, Kevin, we are together. Wafula, Luanda, did I see your thumbs up? I saw for Koech.
Yes, I did.
Okay, nice. So we are together up to that point, right?
Yes, we are.
Okay, good. Any question, guys? Any questions on that is the distribution part? Maybe what you need here it's more practice, and maybe you try to see that is to compare that is what you do on daily basis, and see which model or which distribution will fit you will perfectly fit your that is the distribution of your own choice. Okay, and for you maybe for you to that is to determine which distribution you want to use. Okay, you'll have of course to go through the different properties of what of the of distributions. Okay, so it's the properties of distributions and also properties that is the nature of your data set, which will determine, okay, which will determine the type of distribution you are going to use. Okay, like for example, if we are dealing with count, we are counting maybe some events. Okay, so of course that you will go to what will go to Poisson distribution perfectly. Okay, but what about if we are trying to make that is our data as majorly two possible outcome, like it might have a win or a lose, or yes and no. Okay, so in that case, definitely it will what? It will fall under binomial distribution. Okay, and other that is and other distribution, of course. So maybe heads up here. That is for you to determine the type of distribution you use. You check the nature of your that is of your data set, and also you for you to know the best also to which distribution to apply, you will have also to check the different probabilities of what of each distribution. Good. I hope we are we are together up to that point, and ready maybe now to that is to wrap it up with sampling methods. Okay, good. Let me now start with sampling methods. It's very easy. Okay, sampling methods are very easy. Like for example, maybe you might decide, maybe in this case, to get what, to get a sample, maybe reviews. Okay, from what? By randomly selecting some few people. Okay, like I may decide to select maybe Mondi to give us a review. I might decide to that is select Maureen. I might decide to select Peter Simon. Okay, I'm now selecting randomly, and of course that is a way of doing sampling. Okay, again, I might now decide to be most systematic, and then I try to say I will go maybe if I select the first one, I will jump the second person and select the third, jump the fourth and select the fifth. Okay, so I might decide to go with odd numbers count. Okay, like if maybe in this list you are on that is you are on odd, That is, or maybe if you are counting, your count is odd, okay, then um, you give us a review. That's another way of sampling, okay. Maybe I might now decide to go what by per country, because here we have different people from different countries. I might decide, let me have reviews from guys in Rwanda, let me have reviews from guys in that is from guys in let's say Kenya, from guys from South Africa, and guys from what? Maybe Ireland. Okay. I might decide to do what? To sample that. Okay. All right. So those are different types of sampling. Okay. And that's what we are going to cover here. So of course I had discussed about population and sample. And of course, population is the entire maybe population you are trying to study. Okay, let's say maybe you are in a company with a population of 90,000 people. So that is what? That is our what? That is our population. Then we have a sample. Of course it will be hard for us to like to, if it is to interview or to get some feedbacks, to get feedbacks from the 90 people. Okay, so in this case I might decide to do what? To take a portion of that population to represent the others. So now that becomes the simple, that is the sample, the sample that is our sample data. Okay, so first you need to understand the difference between population and sample, and identify the target population of your research. So the population is the entire group that you want to draw conclusion about. Okay, and then sample is the specific group of individuals that will collect data that is data from. Okay, and this specific group of individuals, we are taking them from what? From the population. So population is the entire group you are trying to study. Okay, so of course now after that we have what we call that is sampling frame. Sampling frame. So for sampling frame, it is the actual list. It's like more of the that is it is more of the entire population. Okay, like the entire population. So the sampling frame is the actual list of individuals that the sample will be drawn from. Ideally it should include the entire what? Target population. Okay, so like for example, you are doing a research on working condition at a social media marketing company, or let's say you are doing a research on working condition in your company. Okay, and your population, or you have a population of that is 1,000 employees in the company. Okay, so meaning we have data for 1,000 employees kept by what? By the HR department. Okay, so our sampling frame is the company's HR database, which is the list of the and the contact details for every employee, or for all the 1,000 employees. So data frame is what? It is basically that is the population. Okay, all the details of all that is these employees, if we are to use this example. And for this case we are going to use the example of maybe a company. Okay, so these will be what? A sampling frame, where the sample data will be what? Will be drawn from. Okay, then of course we have now the probability sampling methods. Now these are the sampling methods which we are going to use, and of course they are what? They are probabilistic. Okay, or they are probability sampling methods. Okay, so probability sampling means that every member of the population has a chance of being selected. Okay, so every member of what? That is of the population. Okay, has a chance of being what? Has a chance of being selected to be a sample. Okay, so it is mainly used in quantitative research. If you want to produce results that are representative of the whole population, then the probability sampling techniques are the most valid choices. Okay, and we usually have four major types of probability sampling methods. Okay, that is, we have the sample random sampling, we also have systematic sampling, we have stratified sampling, and we have cluster sampling. Those are the major four types of what? Sampling. Good. Let's start with the first symbol, random sampling. From the term random, meaning we are selecting randomly, okay? We are randomly selecting what? Our sample from the population, okay? So it does not have any specific what? Pattern, okay? Good. So in a simple random sample, every member of population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators, or that is other techniques that are based that is entirely on chances. Okay, of course we have random that is sampling generators. Like for example, if I have a list of all these employees, okay, if I have a list of all these employees, okay, let's say we have their names here, the names of the 1,000 employees. Okay, I might now decide to give them what? To give them a specific what? Specific value. That is, let's say ranging from 1 to up to 1,000. Okay, and then I can decide to generate. Okay, like for example, we have random. Okay, we have rad. Okay, and under rad I can generate what? I can try to generate 10 random numbers out of the population of what? Of 1,000. Okay, so sorry, we have rad. Okay, I think we should be having rad between. Okay, so let's assume I want to do what? To do a random of that is the top. Of course we have maybe the bottom between. Let's say now if I want to generate like some random generators, I want to generate between that is 1 to what? To 100 people, like a sample of 100 people. Okay, so in this case I can just try to do what? To do some what? To do some random generation. Okay, I can decide to do like some random values, and you can see if we try to change, you can see you can do what? If you can if we try to change, the random numbers does what? They do change. Okay, so maybe for this you'll have to use the formula once, otherwise it will keep what? It will keep maybe generating other values. Okay, like for example, I have generated that is 7 random that is values. Okay, that is 98, 54, 58, that is 96, 20, 95, 22, 21, and 42. Okay, so this it has just generated 7 values between what? Between 1 and what? 100. Okay, so in this case I might now go and pick the 98th person, the 54th person, the 58th person, or just even don't use that is the random generator. I can decide to go eventually and say I'm going to pick this person from this department, pick this person from this department, all that. Okay, like you are randomly selecting people. Okay, like for example, you want to select a sample of that is a random sample of 1,000 employees over social media or in your company. Okay, you assign a number to every employee in the company database from 1 to 1000 and use a random number generator to select maybe 100 numbers. Okay, so out of those 100 numbers, now you will get what? You will get now the what? You will get that is the head which you need. Okay, so you can see even from this diagram, we don't have any specific pattern. So you can see this person selected the first one, went to the fourth, went to the eighth, went to the ninth, went to 11th. Okay, so like you don't have any specific pattern. Okay, so you are randomly selecting your sample. Are we together up to that point? Is a random sample clear? Thumbs up if the random sampling method is clear. Okay, good. I guess we are good. Are we good? Aim? It's long time since I saw you in the class. We are together, Aim?
Yes, we are together, sir.
Okay,
I'm very sorry that these 2 days I had the sickness. That
oh,
yeah, that could not allow me to watch into the computer too much.
okay, sorry,
That's
but I
why.
hope
Yeah,
you are now
yeah,
improving.
yeah, I'm
You are
getting
now
recovering
okay. Quick
because of the
recovery, sir.
flu and yeah,
Yeah, yeah.
and the headache.
Okay.
Yeah.
Have a quick recovery. We'll
Okay, thank you,
we'll
sir.
pray for you.
Thank you, thank you.
Okay, good. Since we are all together. Okay, now let's continue to the systematic sampling. So now under systematic sampling, it's now we are following a systematic, or we are following what? A system. Like if I might decide to get what? The odd numbers. Okay. So my samples to be like all the odd numbers between maybe 100 people. Okay. Or select 100 people. Or maybe I want like the 10th, the 20th, the 30th, the 40th person, okay, to be what? To be, that is, to be my sample. As you can see from the diagram here, we've taken that is the second, we will now take that is, we'll jump to take the next person, jump to take the other person, jump to take the other person, jump to take the, like we have a systematic what approach on that. So systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. That is the systematic sampling. Why? Every member of the population is listed with a number. But instead of randomly generating the number, individuals are chosen at what? Regular intervals. So in this case, we are selecting what? That is the employees at a regular interval. Like for example, all employees of the company are listed in alphabetical order. From the first to 10 numbers, you randomly select starting point like 6. Then from 6 onwards, every 10th person on the list is what? Is selected. Meaning, if we take the sixth person to be the first person, then the 16th person, you will select that the 16th person, then the 26th person with what? With a step of what? Of 10. Like you are taking every 10th person. Okay. Let me add, that is allow someone in. Okay. So in that case, I will be what? I will be taking the what? The 10th person. Okay. So in this and so on. So you will end up maybe with a sample of what? 100 people. Okay, so in this case, out of the 1,000, I can take a sample number of 100 people using this systematic what? Systematic method of sampling. Good. I hope we are also good up to that point. Amwai, Brian, we are all good. Koech, Maureen, okay. We have Alleluia. Alleluia, you have a question?
Yeah, yeah, thank you. So, my question was on like I was wondering on an example and questioning what will be the type of sample in that case. Like if, for instance, you like in the example that you are giving of employees, if you decide to take, let's say, 5 person randomly, but from each of the department, like for instance, you have 5 departments and you decide to take 5 person from each of the department, but then take those 5 randomly. So what will be that type? Is it really random or systematic?
Good. Now, I want to keep that question, you to keep that question. Okay, we got the next two, and then if you won't be answered by that is at that point, okay, you will let me know, or you will ask the question again, because we also are going to
Okay.
cluster, like where, or and also stratified, where maybe we might be checking on what certain groups with same characteristics. Okay, like for example, if you are in IT department, we might be having 10 IT guys. Okay, if we go to that is, we might also go to another department and find that we are having what, another 12 people. Okay, and of course we can take all those 12 and 10. So in that case, we are going to combine two, that is sampling methods. Okay, in that case, and you'll see we have a name of a sampling method which does what, which does combine that. Okay, good. Let me admit someone. Okay, good. Let's now go to stratified. Okay, let's go to stratified. So stratified sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. So, to use this sampling method, you divide the population into subgroups called stratas. Okay, based on the relevant characteristics, either gender identity, age range, income bracket, job role. Okay, whereby now if we are talking about department, we are grouping them according to job role. Okay, like we are coming like with a group of IT team, operations team, okay, HR teams. So you can see those are stratas. So out of the 1,000, okay, we will be what? We'll be now taking these stratas. Okay. Then now after getting, let's say, these stratas, let's assume we are having 3 stratas. Like HR, we have 10 people. We have IT, 10 people. And what? Maybe operations, we have 10 people. I'm assuming a population of what? Of 30. Okay? That is my assumption. So in this case, you might not want to do what? To get your sample, like to take all of them as your sample. Okay? What if maybe they are more than 10? Like each department is having like 100. Okay? So in this case you have to do what? You have to group them into stratas, those departments, different departments. Then after that, you have to now to either use random selection, like out if it is IT, you need like 3 people out of the 10. You can randomly select them, or you can systematically as well select them. Okay, so you can see this here involves you first of all dividing or putting that is your population into stratas or subgroups, and then doing what? Sampling that is out of those groups. So in this case we are saying that based on the overall proportion of the population, you calculate how many people should be sampled from each subgroup. Then use random or systematic sampling to select what? To select a sample from what? From each subgroup. Okay? Now, hallelujah. Is your question answered?
Yes, sir.
Good.
Thank you.
Good. So in that case, you will what? You'll have to first of all group that is your sampling into stratas, okay, to your population into stratas, and then either use either systematic or random sampling that is to do what? To select your sampling. So like for example, the company has of course a total of 1,000 people, okay, whereby 800 are what? Are female employees and 200 are males employees. You want to that, so in this case we've grouped these people into two what? Into two stratas, females and what? And males. Okay, so you want to ensure that the sample reflects the gender balance of the company, so you sort the population into two stratas based on gender. Then out of those stratas you might decide to take randomly 80 women from the 800 females and 20 males from the what? From the 200 males. Okay, which gives you a representative sample of what? Of 100 people. So that is stratified sampling. Are we good? Are we together on that? If we are together on strata, Peter, Simon, are we together? Good, good. I can see most of us, we are together. All right, good. Now let's go to the last sampling method. Okay, we are going to the last sampling method, that is cluster sampling methods. Okay, let's assume maybe your company has different has branches in different what? In different countries. Like it let's assume it has, maybe your company has another 10 branches or subsidiaries, okay, in different what? In different countries. And of course for you, you are of course, remember we are trying to do a research on the employees feedback on the working environment of your company. If the company is giving it's providing a good working environment, okay, so in this case of course it might be expensive, it might be expensive to go that is to all those 10 countries, okay, to do what? To conduct maybe that is research, okay. But maybe you might decide to go, maybe you might decide to go to 3 out of the 10, meaning now those 3 branches, okay, all those the branch these 3 branches in different countries will give us like an overall feedback about what? about our all 10 branches. Okay, so cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Take note of this. Here, cluster sampling involves dividing the population into subgroups, but now each subgroup should have similar characteristics to the whole what? To the whole sample. Instead of sampling individuals from each subgroup, you randomly select an entire subgroup. Okay, like for example, if we are now talking about an office, of course, if it is an office, we have like the three departments. Okay, we have HR, operation, and IT. If you go to another country, we have HR, operation, IT. Okay, not maybe in one of the offices we only have HR. Maybe the IT is in another office. No, like we have the same what that is characteristics. Okay, so if it is practically possible, you might include every individual from each sample cluster. If the cluster themselves are large, you can also sample individuals within each cluster using one of the techniques above. Okay, this is called multi-stage sampling. Okay, this is called multi-stage sampling. This method is good for dealing with large and dispersed population, but there is more risk of error in the sample, okay, as there could be substantial difference between the clusters. It's difficult to guarantee that the sampled cluster are really representative of the what? Of the whole population. Okay, so that's why we said if maybe these subgroups don't have the same characteristics, then it might be tricky, okay, or it might not be representative of the whole population. Maybe an example might give us more meaning on this. Okay, so let's assume the company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. Okay, you don't have to travel. You don't have the capacity to travel to every office to collect your data. So you may you may use random sampling to select 3 offices out of what? Out of the 10 offices. Okay, then these will be what? These will be your clusters. So meaning you will only conduct maybe or collect your data from these 3 offices, but be a representative of what? Of the whole population. That's all about cluster sampling, and that's all about the sampling methods. Are we together on this? That is on the last sampling method. Good. Then that is